Lesson 2.5, Solving Systems of Inequalities. It's standard MA 912, AR 9.5. Something to remember is a system of inequalities. Just think of standard form as well. It is going to be a system that has two or more inequalities with the same variable. The feasible region is the intersection of the graphs. So now the feasible region could be bounded, means the graph of the system is polygonal, which means it looks like it could be rectangular, trapezoidal, whatnot, or it could be unbounded, so it forms a region that is open. Some key concepts to remember is that you're going to graph each inequality by graphing the related inequality equation and shade the correct region. Normally test the ordered pair 0, 0. Then step 2 is identify the feasible region that is shaded for all the inequalities, which means where's the overlapping colors. So if we look at example 1, in example 1 it wants us to solve the system of inequalities, and it's going to be an unbounded region. So they gave us the equation y less than or equal to 4x minus 3, negative 2y greater than x. Knowing the equations, when we look at the first one, we're going to use a solid line for inequality number 1 because it says less than or equal to. The appropriate half of the plane is going to be shaded yellow, which means they use the equation, and notice that here's the origin point, and the equation was to the right of it. So I plugged in 0, 0 into the equation. Basically, you say 0 is less than 4 times 0 minus 3. 0 is smaller than negative 3. That is a false statement. So 0, 0 was to the left of the line, so I shade to the right of the line. The appropriate shade. So now we're going to use a dashed line to graph the second bound value. It says y, think of it as y equal to negative 0.5x. So and then you do the same thing. Negative 2 times 0 is greater than 0. 0 is greater than 0. That's not feasible. So we're going straight through the origin point. So then you have to pick a point to the right or to the left of it. So I would test a value of negative 2, negative 1. When y is negative 1 and x is negative 2, you plug in and you see negative 2 times a negative 1 greater than a negative 2. Positive 2 is greater than 2, and that's why we shaded downward. So the solution system is going to set up ordered pairs in the intersection of the graded graphs. So we're looking at the green, the overlapping. So the feasible region is unbounded. Now when we go to our check, it says test the solution by substituting the coordinate of a point in the unbounded region. So they tested the points 2, negative 3 and replaced x and y to see if it was a true statement. So when they plugged in negative 2 for x and negative 3 for y on the first equation, it resulted in negative 3 is less than or equal to 5. That is a true statement. When they plugged in for the y and the x again on the other one, 6 was greater than 2, and that is also a true statement. So let's look at our check problem. It says graph the solution of systems of inequalities. So they gave us 3 equations. So equation 1, equation 2, and equation 3. The first one is going to be solid because there's a line underneath it. The second one's going to be opened or dashed. And the third one is going to be solid as well. So first thing, the first one starts at positive 2 on the y-axis, and the slope says I'm going up 1 over 3. So I went up 1 over 1, 2, 3. And I have a solid line going to my point. So I'm going to go ahead and test my value in my equation of 0, 0 because I did not go through the origin. So I'm saying 0 is smaller than 1/3 times 0 plus 2. 0 is smaller than or equal to 2, and that is a true statement. So for that reason, I am going to shade down because 0, 0 worked. The next one is saying we're going through, it says y is greater than x. So think of it as starting at the origin, you're going up 1 over 1, up 1 over 1, and it's a dashed line on your graph. But for this one, since we did not go through since we use the origin, we're going to pick another point. So I'm going to pick the point -2, 4. I'm going to test -2, 4. 4 is bigger than -2. That is a true statement. So it means for that one, we are shading up. And in our third one, it says y is less than or equal to 1. So at 1 on the y line, we have a solid dot. It is going solid dot going left to right through it. It says all the values of x have to be smaller than 1, which means I am going down. So the answer is where they all overlap. And for this purpose, all our problems overlap where this piece is, right in this section, is our feasible region. In example 2, a bounded region. So it says all the system inequalities, and they gave us 3 inequalities, and they gave us our pieces. The first one we notice is dashed. The second one is going to be a solid line, and the third one is going to be a dashed line. So again, for the first one, use a blank line to graph the first boundary. So the first one, again, is going to be a dashed line. And then shade the appropriate regions. So now the appropriate regions for the first one, we're going to be 1, 2, 3, and 7. Because if I look at the first one, which is this line right here, started at +5 and came down, negative slope. We started at +5 and came down 4 and then over 3. That's why we have a dashed line. 1, 7, 2, and 3 are all below to the left of that line. Then we're going to use a solid line for the next region, which it started at -2 and we went up 1 over 1, up 1 over 1. That's why we have this line right here, this equation number 2. And then we tested again 0, 0. When you test 0, 0, 0 is bigger than -2. That's true, and that would be shading above the line. So we are regions 1, 5, 6, and 7. 1, 5, 6, and 7. Then for the third one, third inequality, we are a dashed line again. And so we plotted our point at x equal to 1, and it says all the values of x have to be to the right of it. So to the right of it are regions 5, 7, 4, and 3. So 3, 4, 5, and 7 are to the right of that piece. Now, remember, this is a bounded region. So the solution of the system is the set of ordered pairs in the intersections of the graph, which is the dark blue, which is 7. The feasible region is bounded. Our feasible region is bounded because notice that there is no open view. It's that trigonal piece right there. And our check problem says graph the system's equation. So again, we have our 1, our 2, and our 3. Our first one is a solid line starting at -3. And the slope says I'm going up 4, 2, 3, 4 over 5. And I have a solid line. I'm going to test the origin point. So again, I'm going to test 0, 0 for that one. Did not go through 0, 0. So 0 bigger than equal to 4/5 times 0 minus 3. 0 is bigger than or equal to -3. That is a true statement. For that region, we are shading above the line. When we go to the next one, it is a dashed line starting at +2, and we're going down 2 over 3. 2, 3, and it's a dashed line. Again, we did not go through the origin, so I'm going to use 0, 0 to test. 0 is less than -2/3 times 0 plus 2. 0 is smaller than 2. That is a true statement. For that reason, 0 works, so I'm shading down. And then the third one says x is greater than 0. So again, we're going to be a solid line. X at 0, solid line going up and down. And it says all the values of x have to be greater than that. So we are shading to the right. And our solution is this piece in the middle, the common overlap, which is our triangle in the middle. Okay, in example 3, using systems of inequalities, so it's our word problem. It's based on tours. And this one it says Niagara Falls Boat Tour Company charges $19.50 for adult tickets and $11 for children's tickets. As each boat has a capacity of having 600 passengers, including 8 crew members. Then it says suppose the company's operating cost for one boat tour is $2,750. Write and graph a system of inequalities to represent this situation so the company will make a profit on each tour. Then identify some viable solutions. Okay, so on this one, we're going to let A represent the adult tickets. C is going to represent the children's tickets. So inequality number 1 is going to be adult tickets plus children's tickets plus 8, because there's 8 crew members, has to be less than or equal to 600 because it says the boat can hold 600 passengers. The next one says equality 2, something A plus something C is greater than $27.50. Remember, this is money, so we need to do cost. So it's $19.50 for adult tickets, $11 for children tickets. Inequality C3, the third one, means we have to have more than 0 adults attend. That's why we have A is greater than or equal to 0. And equality 4 is going to be C is greater than or equal to 0. So for part B, they want us to graph our pieces. So the first one said, remember, inequality 1 started at A plus C. A plus C plus 8 is less than or equal to 600. So technically A plus C is less than or equal to 592. That's why we have a solid dot here at about 592, almost 600. And it was a negative slope because we're going to basically solve for, you can solve for A or for C, does not matter. It's going downhill. When we shade, remember, we have to be less than that region. So that's why for that piece, we are shading below the graph. You're going to shade below the line for that one. The second one says it's 1950 A plus 11C is greater than or equal to 2750. So you kind of think about that one as being y equals mx plus b. Y equals mx plus b. So what we did also, you can do your x and y intercepts. Think of it as 1950A equaling 2750 to find where on the x-axis I'm going to be. And then the 11C equal to 2750 to find where you're going to be on the y-axis. Hence, we have children tickets are the y position and adult tickets are the x position. Obviously, inequality A and inequality 3 and 4 have to be shaded above the line because you want to have more than 0 passengers. Now, notice that the green over here is where they overlap. So our feasible region is this region in between our parts. So then for that piece, they're going to ask us, we're going to ask some questions about feasible regions. So we're going to go back and forth. It says 60 adult tickets and 100 children tickets. So we have to go check, does 60 adults and 100 work? Well, 60 adults would be down here and 100 kids. That's not in the feasible region. So that is not viable. 210 adults and 350 children. 210 falls in the grouping here and 350 falls in the grouping here. So it is viable to use that piece. 415 adults and 200 children. 415 adults. Yes, here's 415, but it said we had a total of 200 children. So when we look at our graph, here's 200. If I go over 315, 415 is about here. That's where that point is, above the region. So it's not a viable value. 390 adults and 240 children. 390 falls somewhere here, and 350 falls above it. So we're looking at another region up here. You're outside the boundary. So we are not viable. 550 adults and no kids. Well, 550 happens to be here inside the region with no kids. So that is, you could just do adults for that problem.